hollow hoop, solid block. Right? Both same radius and slightly magnetic.
Slightly?
Slightly?
No, I think you may have it wrong there.
Just kidding.
Okay, I lied. They are magnetic.
Yeah, that was really good.
You got it.
That was impressive.
But how do their weights feel compared to each other?
Kind of both the same.
Same weight, except one is spread all the way out and one is a solid disc.
Leave it hollow.
Do you guys remember what inertia was from? No, it's
Yeah.
not hollow. It's solid. It's just a less dense material.
I know what it is.
Do you guys remember what inertia is from
See
months ago?
Yeah. Resist change in motion.
What does that mean?
Stay-puttiness.
Stay-puttiness. So what's going to have more inertia? Yeah, give me like.
Is that a bad mood?
What's going to have more inertia? This pencil or this block?
The block.
Would somebody try to flick them and see which one's easier to move?
Oh, I want to flick the pencil.
I want to flick the block.
Now flick the pencil. Okay, which one was harder to move?
The block. The block.
How did you do that?
It's because he went.
No, I just have
Give me that.
Block, please.
Sure.
So now, with these two objects, since they're the same weight and same radius, which one do you think is going to have more inertia, or are they going to have the same?
I think it's
Do you think that one might have more? Like if you like have going like this way, like you know, there's less air resistance.
So you think it has to do with air resistance?
Yeah, like
I'm telling you right now, it's not air resistance. That's a really good guess.
oh,
Gravitational pull.
gravity would be the same.
friction.
Yeah.
Okay, yeah, Jericho said
It's center.
I'm gonna go with that.
Would it be?
They would both have this.
Balance?
They would both have the same amount of friction because they both have the same amount of area in contact with the table. Good guess though.
Would it, the center of mass be different?
The center of mass is different. Where is the center of mass on this one?
On the outside.
It's farther out, right? What about this guy?
Everywhere.
Yeah, so it's kind of about halfway out. So this one it's all the way at the edge, and this one it's halfway out the radius. So which one's going to be harder to accelerate? You might want to pick up your phone, by the way.
I want to be able to catch it.
So if I lift the table, which one's going to roll faster? Which one's going to have less stay-puttiness, less inertia?
The bigger,
The
hollow.
No, solid.
The solid one.
The solid.
the hollow one because
Solid.
So you think this one has more inertia? It's harder to get to move.
Oh, no.
Yeah, it's the air goes. Yes. The air goes into this one and stops.
Brant, the air has nothing to do
I'm
with
telling you, it's not air resistance.
We've already said that.
It's based on inertia.
it.
Which one has more inertia? Which one's going to be harder to move?
the solid one's going to be harder to move.
Well, this is something I want each of you to try to guess in your heads. You don't have to say it out loud. Which one do you really think is going to be harder to move? Let's try it.
They're about the same.
Wow, nice roll. Oh, wow.
Let's try it again.
Swerve.
Oops.
Starting the game.
I do.
Maybe you should like bring the table up and then make some
Oh,
of
that makes
it.
life easy. Ready? Set? Go.
Ah.
Well, they're gonna hit each other.
No, they aren't.
Which one moved more easily?
This
That
one.
one.
Solid block.
Why? Why would the solid disc move more easily than the hoop?
Because once you get it going, it's the weight just keeps it rolling. Whereas that one, it can stop pretty much
For going.
whenever once it's.
Wait, even more, why was that one... Can I see him? Why is this one harder to get to move?
Because there's not enough there for gravity to pull on. Like,
But they have the same mass, they have the same weight. So gravity's still pulling on the same amount of particles.
Hey, Brent, question is, how deaf are you?
What is that? No, unacceptable.
You can't gravity like pull on this, and it can't pull on this.
I have respect. Being a douche.
It's a good guess. That's why. They both have the same amount of mass, so I'm telling you for a fact, gravity is pulling on this one as strong as it's on this one. Because, would you want your hands out? If I drop it, it pulls them both down at the same time. Good guess though.
Is it because like the mass is more evenly distributed in the solid one?
It's still evenly distributed.
You're
But
at the
for this one, where is most of the mass located?
on the outside.
On the outside.
Around the outside.
Around the outside. 2 trailer park girls.
Yes!
Aha.
And this one, it's located closer to
Oh.
the center, right?
Yes.
So this inertia,
You need to know the sign.
the stay-puttiness, is equal to mass times the radius squared. And we've decided they both have the same mass, right?
Yep.
At least for rolling objects, that's what it is. But which one has the bigger radius? Which one's more spread out?
The solid one.
The solid one.
How come
Or wait, no, not the solid one.
The non-solid.
Which one has the mass more towards the outside?
That
Oh.
one.
Okay.
The hoop. All of the mass is at the outside, right? So this one has more
Radius.
Radius.
which means it has more
Inertia.
inertia, which means it's going to be harder to get it to move. Harder to get it to accelerate. Yeah.
So radius isn't just like measuring like how the length from the center out. Is it also like how much like
It is, but it's where we're locating the center of mass. Or not the center of mass, because the center of mass for both of them is still in the direct center, but where most of the mass is located.
okay.
So when we're talking about objects rolling, for a solid one, the center would be around there. And if we talk about a solid cylinder, Mariana, you might be able to help me out. Solid cylinder, the equation is 1/2 mr squared. So that's for a cylinder, but when we talk about a hoop, it's equal to just mr squared. So you can see, the inertia of the cylinder is going to be about 1/2 of the inertia of the
Radius. No.
hoop. And you can tell this when you try to roll them. If I push on these both with equal effort, here, try to roll them both toward me at the same velocity.
1, 2, 3.
One person try it.
Yeah.
Yeah, Kira.
I got this.
You got this?
No, one hand in the middle. Like
And then we try to stop them. Which one was harder to stop?
That one.
This one.
Why was that one harder to stop?
Because it's most of it's.
Someone knew. Why was that one harder to stop? Why was the hoop harder to stop?
Because the mass is more towards the outside.
Which means it has more inertia. You guys with me on this? This has absolutely nothing to do with what you were